So we have a problem where it asks, does the series 5 over 2n squared plus 3 converge, where n goes from 1 to infinity? We're going to look at this, we're going to solve it two ways. We're going to answer this by using the comparison test first, and then the limit comparison test. So I just want to emphasize how each is used so you can see the distinction. So the first way is with the comparison test. And so what we're going to do is we're going to think of something that's nicer to look at than this 5 over 2n squared plus 3. So what comes to mind is trying kind of chopping off that plus 3. That would make my life a little easier. I'm just going to go with that. And so 5 over 2n squared, that right there, if I take off that 3, then that's going to make it bigger than 5 over 2n squared plus 3. So I have that comparison. So what would be ideal is now if this greater one converged, then this less one is going to converge as well because it's less than. So let's look at this. Let's look at what I just created, 5 over 2n squared. So that series, so the summation of 5 over 2n squared as n equals 1 to infinity, that I could write as equal to, pull that coefficient out, 5 over 2 times the sum of n equals 1 to infinity of 1 over n squared. And that's great now because 1 over n squared, this is a p-series. They do donuts outside my house, and we keep trying to catch them. So anyways, any of you doing homework out there and trying to find a quiet spot, hope you found a quiet spot. I don't have any. Anyways, the 1 over n squared. So we have this p-series where p greater than 1 converges. So we know that. And so that's enough to write that. We already established that before. And since 5 over 2n squared plus 3 is less than 5 over 2n squared, then we get to say that our original summation of n equals 1 to infinity of 5 over 2n squared plus 3 also converges because it's less than. And so this would be by the comparison test. Now let's go and try this by the limit comparison test. All right, so by the limit comparison test, I have this summation of n equals 1 to infinity of 5 over 2n squared plus 3. And what we can do here is we want to choose a b sub n. And so some of the things that you'll see is how do I choose that? Well, taking the lead term. So in the top we just have this 5, but and I could choose the 5, but a multiple is not going to really change much, and so I'm going to actually just choose a 1 for my numerator. And then my denominator lead term is this 2n squared. I'm going to simplify that even further and just say n squared. Because what I'm going to do is take the ratio of my a sub n, b sub n. So my a sub n is going to be called this 5 over 2n squared plus 3. And I'm going to do a little scratch work so I don't have to keep pulling my limits through and rewriting them. So I'm going to look at a over n, a sub n over b sub n, and that's equal to 5 over 2n squared plus 3 all over 1 over n squared. And so let's just do a little bit of algebra here. 5 over 2n squared plus 3 times n squared over 1. And this is, this is equal to, and so then this is equal to 5n squared all over 2n squared plus 3. And because I'm going to be taking a limit, I want to use the technique of cleaning up my n squareds there, because right now I just have everything going to infinities if I were to take the limit as n goes to infinity. So let's go ahead and multiply the top and bottom by 1 over n squared. I'm just choosing that highest highest degree. And so if I do this, I'll go ahead and show the work on this, but you can fast forward if you want. 5n squared over n squared all over 2n squared over n squared plus 3 over n squared, because that 1 over n squared has to distribute to both terms on the bottom. And then we have some things canceling out here. N squareds are gone, so I now have 5 over 2 plus 3 over n squared. And so that's what I'm going to take with me to talk about the limit. So now I can look at the limit using my limit comparison test as n goes to infinity of a sub n over b sub n is equal to the limit as n goes to infinity of 5 over, gotta go find it again, what was it? 5 over 2 plus 3 over n squared. Okay, so this is what I have. And so we'll notice if we were to pull the limit in, I'm not going to show all that work, but using our limit rules, if I pull, or limit laws, use the limit, pull it in, the limit of 3 over n squared, that is equal to 0, so this whole thing would be 5 over 2 plus 0, which is 5 over 2. And the big deal of that, if we call that C by the limit comparison test, that's greater than 0. So we know the summation of the series of a sub n and the series of b sub n either both converge or both diverge. And this is by the limit comparison test. And so we have this by the limit comparison test. So now we need to just figure out, do they converge or diverge together? Well, we have, the reason we chose the b sub n in the first place is we wanted something nice to talk about in terms of convergence. So let's look at the series of 1 over n squared, and goes from 1 to infinity. And then because this is p series, we know it converges, and that p is greater than 1. And so we know it converges. So thus, if the series of 1 over n squared, which was our b sub n, converges, so we know that the series of 5 over 2n squared plus 3, we know that that one from n equals 1 to infinity converges by limit comparison test. So we did the same problem twice, showing it by the two different methods, and if I just scan out here, we can see that's the work for the limit comparison test. It takes up about the whole page. And the work for the comparison test, a little bit nicer in terms of quantity of work having to be shown, but when you're stuck on the comparison test, limit comparison test becomes a very nice tool to have.